In this short video, I'm going to show you how to calibrate different parameters of IDF function. In this scenario, this is the IDF function that we are using, and it has 4 different parameters, A, C, B, and N. And different variables in this equation are I is rainfall intensity, millimeters per hour, capital T is return period, and small t is duration in minutes. All right, so this table is the table that has been given to you by the problem statement. I have selected only the durations and return periods that I need. Specifically, I only need 5, 10, and 15 minutes for duration, and I only need 1, 2, and 5-year return periods. So these are the numbers that have been observed or observed rainfall intensity for return periods, and the units for these numbers are in millimeters per hour. All right, to start solving this problem, you need to create a table like this. The only difference between this table and this table is that the lower one is going to be estimated rainfall intensity based on this equation. You might say that we do not have the value of A, B, C, or N. How are we going to estimate the value? So over here, you can see that I have some empty cells, and I'm going to assume some numbers for these values. It doesn't matter what number you assume. I'm going to go randomly 2, 1, 2, 1. You could put any number that you want over here. It doesn't matter. All right, now that we have some assumed and hypothetical values for parameters A, B, C, N, we can actually estimate rainfall intensity using this equation because we have durations and we have return periods. So what I'm going to do is writing this equation in this cell and show you the number based on my assumed or hypothetical value. So I'm going to pause the video, write the equation in that cell, and then resume the video again. I have written the equation over here, and I've referred to parameters A, B, C, N over here, and also duration of 5 minutes, return period of 1 year. If I press enter, this would be the value that I have based on these assumptions. So I am going to drag this cell to calculate the values for the other durations and the other return periods. Perfect. This was step 2. Step 2 is done. Now we want to find out the error between these estimations, right? Obviously right now, because my parameters were based on hypothetical assumption, you can see the values are far away from each other, right? So let's find one measure to measure the error between these two. It would be square of normalized errors. And the way it works is you have estimated intensity minus observed intensity divided by observed intensity to the power 2. And that's square of normalized error. So again, I'm going to pause the video, write the equation for the square of normalized error over here, and resume the video. And this is the equation. You can see that I have used the observed value and estimated value of rainfall intensity for the duration of 5 minutes, return period of 1. Pressing enter, this is the value. This is the value of error, squared normalized error. So I'm going to drag it down and to the right to calculate it for all other cells. Now I have it over here. So next step is to calculate summation of the errors for each return period. Over here, summation, I need to write over here. There we go. And then for the next 2 return periods, and then my objective function would be summation of the errors for these 3 cells, my summations. Okay, so the objective function is 8.96, and it represents the total amount of error that exists between the estimated values and observed values. What I want to do is to minimize this error by changing these parameters. So you should be familiar with solver capabilities of Excel. Solver in Excel will help you to minimize an objective function by changing specific cells in Excel. So what you need to do, go to Data, and here under Analyze, you will see Solver. If you cannot see Solver under Data tab of your Excel, it means that you have not added Solver to Excel. There are a couple of easy steps to do that. If you look it up on Google, how to add Solver to Excel, you will find step-by-step procedure of how to do that. Once Solver is added, click on it. It will ask you to set the objective function, and our objective function is cell O33, so it's correct. We want to minimize this cell. It's already on minimize. For you, it might be on maximize or value of, but we want to minimize it. By changing what cells, if I drag this over here, we are going to choose these cells over here, the 4 cells that I have over here. Perfect. And then click solve. After a couple of seconds, you will see that this pops up and the objective function is very close to 0, and that's what we want, right? We want to minimize the objective function. So basically, this is telling me that if I use these parameters in this equation, and by the way, you can, when it's done, when this number is close to 0, you can click OK. What I did tells me that by using these parameters in this equation, I developed an IDF function that can be used to figure out the intensity of rainfalls within the duration of 5 to 15 minutes and return periods of 1 to 5 years. I can give you different variants of this problem, and you should be able to solve the problem using the simple steps that I just told you. I can increase the years over here, return periods. I can increase the duration. I can change delta t. Right now is 5 minutes. I can change it to 20 minutes. But the steps that you need to take to figure out A, C, B, N, or other parameters is exactly the same using Solver in Excel.